Good day, everyone. My name is Nkem Ehuju, and today I will be talking about a comparative study between the performances of polypropylene and polyester non-woven geotextiles when used in landfills. Because migration is taking place from rural areas to urban areas, we've seen an increase in population growth and also in urbanization. And this also leads to an increase in waste production. The thing is that the waste is shifting from organic waste, such as food, to multi-purpose waste, ranging from papers, plastics, and even metals. And then those waste, they end up in landfill. The common thing about landfill is that they have the ability to produce leachates. Leachates, what are leachates? They are chemical aggressive compounds that can percolate into the ground and contaminate the groundwater. And so when engineers are building a landfill, they make sure that the landfill is engineered in such a way that there's going to be little or no infiltration of moisture to prevent leachate production. So for a landfill, we have the final cover, we have the bottom liner, we have the drainage layer. So depending on the size of the landfill, be it big, small, or medium, we can have a leachate detection and a leachate collection system. So as time progresses on these leachates, this landfill, they actually degrade, and there are stages in which the landfill degrades. We have the aerobic stage, we have the acetogenic stage, the anaerobic stage, and the stable methanogenic stage. In the aerobic stage needs oxygen, and it's the shortest stage ever. Thereafter, the succeeding stage is the anaerobic stage. This is the stage where the leachates are being produced. Thereafter, we go to the anaerobic stage. This anaerobic stage is the longest stage ever in the landfill life, in the life of the landfill. And methane is also produced in this stage. The last stage of the landfill degradation is a stable methanogenic stage where the production of methane goes to its peak and eventually decreases. So as this landfill is degrading, the pH value of this leachate is changing from 3 to 12 and to 8. And so the final value of the leachate is usually around 8. The final value of the pH of the waste is usually around 8. So for this research, it is a deck study. No data was collected, no field or laboratory work was done. Instead, we collected reports from various lecturers, from various researchers, government publications, gazettes, journals, and various databases to get our information, where we had to analyze the results and make our conclusions and recommendations. So this is a research framework that talks about the keywords that were used in this study. Some of the keywords include waste, landfills, hazards, leachates, chemical environment, chemical attack, the non-woven geotextiles, and we have the polyester and polypropylene. And the reason we chose polyester and polypropylene is because they are the most common used polymers for producing non-woven geotextiles. And then we had to compare the performances of those two polymers when used in landfills. So the results of the comparison showed that the long-term performance of any non-woven geotextiles are negatively affected by factors such as oxidation, chemical attack, and ultraviolet light. However, we are most concerned with how those non-woven geotextiles are being affected in landfills. In landfills, chemical attack is being initiated by the presence of leachates and the pH value of the soil that is being used for cover or for cap or for liner, whether those soils are acidic or alkaline in nature, and even elevated temperatures. Under elevated temperatures, the rate of degradation of those polymers, they are on the increase. But because leachates are chemical compounds that are very aggressive, they have the ability to interact with the polymer of the geotextiles and change its nature. Some of those changes can include chain scission, cross-linking, increase or even a decrease in crystallinity, swelling of the polymer, and an extraction of the most of the components that were used in producing this polymer. So from the results that we got here, from the discussions gotten from various actors, we understood that polyester degrades by internal and external hydrolysis. Now, what is hydrolysis? Hydrolysis is a chemical reaction in which water molecules break one or more chemical compounds. But because polyesters are produced by condensation polymerization, this hydrolysis is a reverse reaction of the process in which the polyester polymer was produced. So in hydrolysis, water molecule is added to the substance, and this might cause the substance to split into two fragments. This internal hydrolysis occurs in acidic or neutral environments, while external hydrolysis occurs in alkaline environments. And the most dangerous or the most severe hydrolysis takes place in the alkaline environment because it changes the structure. It erodes the surface of the polyester, and that's where degradation takes place faster. So as reported by several authors, we found out that polyester, when subjected to various chemical environments, there's a change in its mechanical properties, such as the tensile strength, the fiber strength, and even the puncture strength. And the change that occurs in polyester is not just mechanical change. The hydraulic properties of the polyester were also altered as a result of this chemical action. The intrinsic viscosity and the permittivity of the polyester was also affected. Now, how does polypropylene degrade? Polypropylene degrades by the action of oxidation. Oxidation is a process in which a polymer reacts with molecular oxygen. This oxygen permeates the amorphous region of the polymer, and then oxidation takes place both at the surface and within the polymer. Now, polypropylene is a semi-crystalline polymer. That is, it has the crystalline region and the amorphous region. So if the tie molecules that bonds this crystalline and the amorphous region are broken, the strength of the polymer eventually reduces, and the structure of the polymer will also change. So reporters have showed that the percentage of crystallinity decreased when they collected polypropylene films that have been buried in some landfills, and this showed that oxidation took place. However, there's one property of polypropylene that stood out. There was an increase in puncture strength when the polypropylene was subjected to chemical aggressive leachate, and this was because of material stiffening and reinforcement. But researchers showed that polypropylene recorded no strength loss, either in acidic or alkaline environments, and even in the waste leachate solutions. So the discussion here is that polyester is more severe, it's more susceptible to degradation in all environments. And the greatest of these degradation took place in highly acidic or highly alkaline environments. While polypropylene, on the other hand, showed no strength loss. Showed little or no strength loss in acidic, alkaline or waste leachates. So it can be used for various chemical environments, unlike polyester. So this table showed a comparison of the strength loss for the polymers, polypropylene and polyester, when they were subjected to various chemical environments. We can see that the most severe loss of strength occurred in alkaline environments for polyester. But then polyesters can be used in acidic or neutral environments, but one should be mindful of this. Why polypropylene shows no strength loss, rather there was an increase in functional strength in the waste leachate environment. So on the suitability of polypropylene, someone might ask, which one should you use? We found out that polypropylene can be used in all environments. However, internal hydrolysis takes place, and over a long time, this might cause some unsuitability. Why polyester should not be used in alkaline environment, because external hydrolysis takes place, and external hydrolysis is more severe, it's dangerous than internal hydrolysis. On the other hand, polypropylene can be used in all chemical environments, irrespective of the pH value. So in conclusion, we found out that polyester degrades by hydrolysis and polypropylene degrades by oxidation. While all polyesters showed a reduction in strength, polypropylene was relatively inert to chemical attack. So we recommend that polyesters should not be used in high alkalinity or high acidic environments, while polypropylene can be used in all environments, irrespective of the chemical nature. Thank you.